Okay, everyone, I'm going to be looking at, in this video, chemical reactions and chemical and physical change. So what we have here is a really neat chemical reaction between ammonium dichromate, mercury thiocyanate, and it's a really neat reaction because, yeah, it releases a lot of heat, light, and there are going to be some gases emitted. But this reaction is really neat because, look, it forms these little long tentacle-like structures. This is like a called an octopus reaction. It's a really, 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 really neat one. And it's an example of a chemical change. We're going to start by looking at some physical changes though first. So these are changes in state or dissolving. So you see here some steam being released. So basically what's happening is the water in here is going from a liquid to a gas. So what's happening behind the scenes is you're adding energy, you're separating the molecules of water, but the molecules are unchanged. You're not changing them, you're just separating them. You're overcoming those intermolecular forces between all of these different molecules. Dissolving, likewise, is very, very similar. You're not changing what's going on in terms of the structure of the molecules. All you're doing is you're dissolving. So what's happening here, I've got sugar, so glucose being dissolved, and all that's happening is the water molecules are getting in between these glucose molecules and then surrounding them, and then this is called dissolving. And you can see here that the glucose molecules remain unchanged. That's the key thing for physical changes. You're not changing the actual molecules or particles. So what's happening here is all you're doing is you're overcoming intermolecular forces. So London dispersion, dipole, or hydrogen. So basically just overcoming them, and then you're not changing the molecule. So when you have a chemical change, you're actually rearranging atoms. You're rearranging the molecules to form new molecules. You're breaking those chemical bonds. So here's a classic example you just saw there, where you've got electricity breaking down water molecules into the 2 hydrogen molecules and 1 oxygen molecule. So basically we are breaking these bonds. They're breaking them, and then you're reforming the atoms into new molecules. So that's the whole idea behind chemical changes. Here you go, a little bit of a balanced chemical reaction here. Same thing here. This would be a methane reaction. This is the one that you saw when we were burning methane in a Bunsen burner. You have a methane molecule combining with 2 oxygens, giving you carbon dioxide and 2 water. Again, what we're doing is we're breaking these bonds over here, rearranging and forming new substances. So this is a quick summary of the differences between them. So you should be copying this down. So again, the key thing is that in chemical changes, atoms are rearranged. Physical, nothing is changing. Chemical changes involve those intramolecular bonds, or breaking those ionic or covalent bonds. Physical changes involve intermolecular forces. You're separating the molecules. You're overcoming these forces. So how do you know that a chemical change happened? What's the evidence? We already learned about this in grade 9. Well, first thing is maybe heat and light are given off, right? You might have a gas is produced. You have some bubbling or fizzing, so a gas is produced. There's some extreme examples here, some really cool ones. Sometimes you have a new color occurring. So this is a really great reaction showing a brand new substance in here. And the new substance basically is nitrogen dioxide, very toxic, but look how beautiful color it has. So it's a new color it could be produced. Sometimes you have a precipitate forming. All right, here we go. You have 2 liquids, and you're going to combine them in slow motion, and you're going to end up with a solid. That solid is called a precipitate. So that precipitate wasn't there before. That solid was not there. So you had 2 liquids, all of a sudden you have a solid. That must be something brand new. And then these are the types of reactions we're going to be going through in this unit. You already saw them in grade 10 as well. So you have a synthesis reaction where 2 atoms or molecules combine to form a larger molecule. Decomposition, where you have 1 molecule breaking down into smaller molecules or atoms. You have a single displacement where you've got 1 atom displacing another. So here A is going to be displacing B, kicking it out. And then now it's combined with C. Double displacement is when you've got 2, binary compounds. And what's happening here is you've got the metal displacing a metal, or a non-metal displacing the non-metal. We'll be looking at those as well. And the last one is the typical combustion reaction. We have a hydrocarbon, something like a CH4 or something like that. So carbohydrate, or hydrocarbon, sorry, combining with oxygen, and it gives you CO2 and water. So these are the classic types of reactions. And again, keep in mind that chemical reactions involve the breaking of bonds, the rearrangement of atoms. Physical changes like dissolving, change of state, nothing changes. The molecule's intact. All you're doing is overcoming those intermolecular forces. So that's it. Quick summary. You should be looking at the note, copying it down, and then we're going to be looking at this unit, each of these reactions in a little bit of detail. Take care.